This is an introduction to three-dimensional vectors. Now, up until now, you've probably worked with x and y, and your x-axis is the red one here, your y-axis is the green one here. And you need to imagine your x-y axis as being something like a flat surface. So if you're sat at a desk now, that tabletop could be the x and the y-axis, and the z-axis is just pointing straight up and below your table. Now I can rotate this around. If you're in GeoGebra, you can do quite a lot of this in the 3D graphing, so you can see how we can rotate it around. Now the vector that starts at 0, 0, so the position vector, and goes up to here, B, is 2, 3, 4. So that means it's gone along the red axis 2, up the y-axis 3, so 2, 3 would be there, and then it goes straight up to 4 there. So we can see that that's the way the vector is written, as a column vector in the same way that you wrote your vectors before. Okay, let's come into a different package here, and just going to write that vector out again. So we have got the vector, let's call it vector u, and we've said that that's 2, 3, 4. Now you need to know of one other way of writing that, and that is also that you can write it in the ijk form. So you can write it as 2i, 3j, and 4k. So you can see here that this is your x part, the j is your y, and the k is your z part. Now, the magnitude of u is really similar to the magnitude of a two-dimensional vector. You're basically going to square each component and you're going to then take the square root. Now the reason for that is, I think it's 29, square root of 29. Now why can you do that? Well, if we look on here, if we were to go along from the start here to 2, 3, so let's make a straight line there of 2, 3, and then we go straight up like that. Now from 2 to 3, that line there I'm going to use Pythagoras for, and find that that line in there is the square root of 2 and 3, so that's 13. My math is correct. And this one in here is there goes straight up 4. And what's more than that is this actually creates a right angle. So if you're at a point on your desk, imagine going straight up, you've created 4. So we've now created a brand new right angled triangle, and to work out the length of this line, we're going to take the 13 and square it, which is just 2 squared plus 3 squared, and that's 4 squared. One final thing we're going to do is look at the angle in here. Now that's the angle that your vector makes with the xy plane. And because of this being a right angled triangle here, we can just use SOHCAHTOA. So I've used tan and said tan to negative 1, 4 divided by root 13. And this one in here, this my theta, the angle it makes with the xy plane, comes out as being 48 degrees. So it's a quick introduction to 3D vectors, really similar to 2D vectors, and a lot of the operations are very, very similar.